Alina is here. So hi, Alina. Hello. Good evening.
It is evening here, but yeah, but good morning to you.
Oh, thank you, Alina. I don't know. Are you ready? Do you want to start now?
I am, but I'm wondering maybe the participant wants to have a short break to maybe grab a drink or something, because we are a bit over time, so maybe we can give people a few minutes to have a break between sessions. What do you think?
If that's okay for you, it's okay for me. So guys,
I don't have any plans today, so I'm okay with waiting, but maybe people can also walk on chat, if they want to have a session right now, or maybe if they want to wait and have a break. So please.
We can check with the crowd. Do you guys want to start on the chat? Are you sleeping? I don't think so. Do you want a coffee? Let's give it a couple of minutes, if you don't mind. How's the weather there? The classic. How is the weather?
It's quite warm today. It's 20 degrees Celsius, which is for early October, quite warm.
Oh,
how is the weather there?
Oh, it's super hot, but the mornings are a bit cold or fresh. Really, it's just fresh air in the morning.
It makes me really sad, because you cannot really travel right now, and every time I hear that it's nice and sunny and warm summer, it makes me rather sad.
You will see it next year or the next one, or feel free to come anytime to Guadalajara. It's a real Mexico, as Heather mentioned.
I think people are it started. Okay.
Yes, let's get started. So, all yours, Alina.
Let me try to share my screen, right?
Yes, please.
Yeah, 1 sec. Okay, you should be seeing it by now, right?
Give me 1 second. It's taking a bit of time, but yeah, I think we can see it now.
Let me go back and forth. Do you see changing the slides? Oh, okay, something happened. Okay, do you see my slides now?
I can see your slides now, and they are moving. Okay.
Awesome. Okay, then I will begin, if you don't mind.
Go ahead, please. Thank you.
Okay, hi everyone. My name is Alina. I do hope that you can hear me, see my slides, but if not, if something went wrong, please let us know and we will try to fix it. So in this session, we will talk about building and running fast and efficient Java microservices with GraalVM. And there is more than one way to do it, so stay tuned and we will talk about it all those ways. So a very quick recap about GraalVM in case you are less familiar with it. GraalVM is a high-performance runtime, and it is capable of running all those languages that you see on top here on slides with high performance. So GraalVM can obviously run Java, JVM languages, right? So languages like Scala, Kotlin, you name it, all that you can normally run on your JVM. Also, GraalVM can run JavaScript and Ruby, and in case you are interested in things like data science, maybe machine learning, you may be looking at R and Python, which you can also run on GraalVM. And last in this list of languages or groups of languages is LLVM kind of languages. So GraalVM also comes with an LLVM runtime, so we can run languages that compile to LLVM bitcode on GraalVM too. And also what's interesting, you can use GraalVM in context of different platforms. The first one you can see below here is OpenJDK, which means you can run your normal unmodified Java applications in the context of OpenJDK with GraalVM. The next one is Node.js, and a very interesting case, you can also use GraalVM in a database. And the last but not least, GraalVM can also run applications in a standalone mode, meaning that it will no longer require you to have a JVM to run applications that will be fully functional, fully working as standalone native executables. And it is also interesting, GraalVM can not only run all those separate languages, but also run applications written in a couple of those languages together, so polyglot applications. And GraalVM will give you this interop, right? Give you those, means to run multiple languages at once, but also it will optimize the whole thing, making sure that your applications run fast. Now, so just to recap, right, why you could be interested in GraalVM and what GraalVM can offer for you. This could be high performance because GraalVM comes with a new compiler that can optimize your application performance really well. Also can offer you fast startup with this native image mode, can offer you polyglot capabilities, and also GraalVM is open source. So these are just a few of the things that probably you can like or be interested about in GraalVM. And if you want to get started with GraalVM, the best source of information and tutorials and examples and all of that would be graalvm.org. That's our main website, and also there you can download GraalVM. It comes in 2 editions, community one, which is open source, and an enterprise one if you are looking for things like for more of an enterprise kind of solution for your applications. And I also want to stop for a second here on the open source aspect of it. So if you attended this session before from Heather, a really great one where she talked a lot about, open source and interacting with community. So GraalVM is also an open source project. You can access it on GitHub, see what's going on in there, see all kinds of different repositories, as you can see in here. And if you're a Java developer, it should be fairly straightforward for you to understand what is happening there. So I really encourage you just to kind of take a look at what is there and maybe, contribute, send a PR, report an issue, or contribute by providing us feedback about what is that you want to see in GraalVM in our roadmap. Now, let's talk specifically about Java microservices, right? So for that, GraalVM can offer you the following. When you choose or when you consider running your application on GraalVM, the first thing you need to do is to make this kind of choice, how exactly you want to run your application, because there GraalVM gives you 2 options, right? You can run your application in JIT mode, like you normally would on your JDK distribution, just with, with a Java command, and you give it your application and it runs in a JIT mode, or you can compile the application to a native image and then run it as this native executable that will have fast startup and will consume significantly less resources. And the idea in the second case, in the native image case, is that you will divide working with your application into 2 parts, right? You will have build process and run process. And the idea is to move all the heavy lifting, all the expensive operations to the build process. So when you compile the application, it will start really fast every single time. That's the difference in terms of how you run your applications. And how you should choose which mode to use, we will get to that in a second later in these slides. So let's talk about this first mode, right, where you run your applications on GraalVM as you would on your OpenJDK or wherever JDK distribution you are using. So in that context, GraalVM will be working with OpenJDK as a platform, just replacing the top-tier compiler, C2, with its own GraalVM compiler. And it's a highly optimizing compiler. It has a bunch of really effective optimizations, such as, for example, aggressive inlining or advanced escape analysis that avoids unnecessary object allocations, this way improving your application performance and also reducing the garbage collection times. And here on this slide, just as maybe an initial kind of evaluation for you and to give you an idea of how well GraalVM can run different kinds of workloads, you can see this is a benchmark suite called Renaissance. And there you can see comparison of GraalVM, both versions against OpenJDK. And I don't know if you can see it very well on the slides on the screen here, but GraalVM is comparable and in many cases faster than OpenJDK. And it's really a good reason for you to try it because the migration here would be very easy. You're just replacing your JDK distribution with GraalVM and your application run as they are without any modification needed from your end. Now, if you're maybe a Scala developer, so if you are using Scala at work, or maybe if you have a pet project in Scala, it is really a good idea for you to look into GraalVM, because for Scala code, GraalVM can offer really significant performance improvements. So out of the box, you can expect around, I would say, starting from 10-15% and up to 30-40% of performance improvements to your application. And why this could be important for you? Because this could mean one of the following things. First of all, you could be serving your user requests better, right, faster, improving your users' experience with your application, making it, faster and more pleasant. Or you can maybe reduce your infrastructure cost or free up your infrastructure resources to other applications and processes. So these are just a few of the reasons to consider performance improvements and where you can get them, in case like here you can get with GraalVM. And we were talking before about this first mode, right, JIT, in which you can run GraalVM in the context of OpenJDK. And I want to talk to you about another one, which is GraalVM native images. And this one is really great and really widely considered and used for microservices specifically. So GraalVM native image, it's a Java program which you compile into this standalone native executable. It will start fast and will need very little memory because it does not run on the JVM, right? So in the end, you get a native executable, and this way you can significantly improve your time of startup and also the amount of resources that you need to run your application. And it works really well with many Java microservice frameworks that we'll also see down along in the presentation. And just a few numbers and how this native image mode compares against the JIT mode. With GraalVM native image, if you're considering it for your microservices, you can achieve startup time improvements up to 50x faster, and also your memory usage could be as low as 5x smaller. So how does it work from the inside, right? And where do those startup performance improvements are coming from? So to build this native image, what you do, you just run GraalVM's native image utility, and you give to this utility your application, like your jar or your class files. And what it will do internally, it will start analyzing your application, trying to find unreachable code, and making sure that the resulting binary includes only the code necessary to run the application, making sure that this binary is very slim and contains only the absolutely necessary code. Another thing that native image will do at the image build time is it will perform heap snapshotting. So your application will start also with a pre-populated version of heap, also improving its startup time. And this way, this resultant binary will be really great for your microservices, especially if you're deploying them to clouds. So just to compare those two, right, we talked about the JIT mode and we talked about the native image mode. So how those two are different in terms of startup time and where is this difference coming from? So in JIT mode, what happens when you start your application, when you start running it, is that you would need time to load the JVM executable itself, to load the classes, to start interpreting, start compiling. And after some time, as your application runs, it will run with the optimized machine code, right? So it's a kind of process that happens over time. In a native image or in AUT mode, what happens, you just load your executable and it can already start running with the optimized code because we already optimized it at the image build time, right? So when you run it, it's already optimized and ready to run from the start. And the same goes for memory, right? So when you consider memory usage, in JIT mode, you would need to keep around memory for the, once again, JVM executable itself, for reflection data, profiling data, all of that. In native image mode, you would only need memory for your application executable and for application data. This is how those two modes of operating are different when it comes to startup and also to memory usage. And if you are choosing, which one to choose and which one will be better for you in your application, how do you make this decision? So if you look at the performance metric metrics like here, right? So when you run application in JIT mode, you will be able to really well optimize it for peak throughput, right? Because at runtime, we have all this information available, and we can really optimize the application performance based on that runtime information. And also, you can optimize for reducing max latency in JIT mode. In native image mode, things will be slightly different. So in native image, as we already discussed, you will be able to optimize for starting fast, for reducing memory usage, and also reducing the packaging size, which could be interesting in some cases, in some deployment scenarios. But overall, the decision you're making will be like that, right? So typically, if you want to optimize for peak throughput or for reducing for max latency, it will be a good idea for you to go with JIT. It could be GraalVM JIT, it could be any other kind of JIT, right? And if you want to optimize for startup and memory usage, then GraalVM native image, the IoT mode would be really a great choice for you. But of course, GraalVM is, evolving, and we are working on it. And the idea that we have is to make it like this, right? Where with native image, you can really optimize for all the dimensions and really have everything at once. Now, I want to talk to you, like, for example, if you are interested in GraalVM, right, and you want to get started, so where do you start, and what will be the first good steps for you? So the number one thing you can do is to go to our demos. We have them on GitHub. We also have them on GraalVM.org, but I think maybe it will be just easier for you to grab them from GitHub. And there you can find a bunch of different applications that you can try. Java applications, Java and other languages, frameworks, without frameworks, all kinds of apps. So getting those demos from us, from our repo, could be one option for you. Another option could be going with one of those frameworks that I mentioned and that work with GraalVM and specifically with GraalVM native image, right? And the first one I want to share with you is Micronaut. So you might have heard about Micronaut. It's a framework that's really great for writing your applications for microservices and for serverless architectures. And also, I know that there is a session in this same conference and even at the same time, but on the other track from Ivan Lopez, who is from the Micronaut team. So I really encourage you to watch the recordings afterwards, right? Because our sessions are happening at the same time. But maybe if you can find and access the recordings afterwards, I think Ivan has really great latest updates to share with you. And I want to share with you some of the measurements that I did just to, once again, to compare those two modes of operating, right? JIT and GraalVM native image. So what I ran here was a Micronaut web service, which was a sample applications just available for requests, and it will respond to those requests with an item from a list, right? And when I write this application, first I ran it in a JIT mode, and I don't know if you can see it well, I hope you do. But when I ran it first time in JIT mode, my cold start is 3.3 seconds. And when I ran it again on the same machine, but just compiled as GraalVM native image, I can reduce it to as low as 0.1 seconds. So that is the startup time and the difference the GraalVM native image can make. But maybe I want to, dig a bit deeper into it and also understand what is my resource usage like. For example, how much CPU does this application consume in both scenarios? And maybe I also want to learn how much it takes, not just to start this application, but also do some valuable work, like, for example, serve my first request. So I measure it the second time here, so the second screenshot. And what I see here that in first scenario, running in JIT mode, my CPU usage is quite high, right? Because we talked about all those expensive operations that are required in JIT mode in the very beginning, right? And then when I run it as a native image, because it's already compiled, optimized, you can see that not only I start fast, but I can also significantly reduce CPU usage. And to make it a bit more, visual for people who, perceive visual information better, here is the same applications and the same metric running in just-in-time mode and in native image mode. And what we are measuring here is CPU usage, which is represented by those red vertical lines, right? And we are measuring memory usage, which is this green horizontal line. And you can see that in just-in-time mode, there is quite a lot of work happening up until the first 3.5 seconds or so. So the CPU is quite busy and memory usage is quite high. And then you can see occasional red spikes when those requests arrive and need to be served, because we send those requests every 1 second or so. When in native image, you see that you can immediately notice, right, how much lower is CPU usage, so the red lines, and also memory usage is also much lower in native image, making it really good for cloud deployments where you typically would pay for things like resources and for how long are you using those resources. Now, another framework that you could be looking at is Helidon. So you can just click through those links. Maybe I can share this presentation with you later. Helidon also has 2 versions. It has Helidon EC, which is more lightweight, and Helidon NP, which offers a macro profile implementation. And once again, to talk about some numbers, in the table above, you can see how you can really speed up your applications with GraalVM native image. And below, when you look at the Docker image size, you can also see that it's significantly low. And this image includes everything that your application needs to run. And one more, there is just 2 more frameworks, so it will not take forever. So one more is Quarkus. Quarkus has this really nice website and quick starts, which you can access. And also this guide how to build a native image of your Quarkus application with GraalVM. And on the right here, you can see that, we're talking about different frameworks, but what is common really is you can see how much of a difference can GraalVM bring to your application, startup performance and memory usage in the native image mode. And the last of those frameworks that I wanted to talk about is Spring Boot. And this screenshot and these measurements are from the very recent, I think, from 2 weeks ago conference, where they shared the state of their current integration with GraalVM. So if you want to run and access the Spring Boot GraalVM native image compatible builds, you can find them on GitHub. There is a project called Spring GraalVM Native, and it also comes with some samples. And what we see on this picture here is they were running Pet Clinic on the JDK and as GraalVM native image executable. And you can see that it was possible for them to achieve startup time of almost 0.2 seconds, right? Which is really a fast way to start an application like this. And I mentioned that when you get this project from a GitHub, it also contains samples. There are really quite a few samples, and I think they keep adding new ones. So if you want to play with them and see how it's working for you, there is really a good way for you to try it. Just get it from GitHub. Now, I'm already, closing this native image part, but just a few important things for you to consider if you will be working with GraalVM native image. So in some cases, GraalVM native image will require you to provide some configuration. This could be for things like reflection, GNI, resource usage, and so on. But there is a good way to do it and to handle this, right? There is a thing called tracing agent that will observe your application behavior and will output that configuration for you. And it will make it really easier for the native image to build your application as an image in case it needs any of this kind of resources. And if you want to learn more about it, there is a link to our Medium blog post. It should be fairly easy for you to read and try it also yourself. And one more interesting thing I want to mention is called profile guided optimizations. So you may be wondering, right, in native image, if we are compiling everything in advance, right, at the image build time, how do I optimize it specifically for the profiles for the runtime behavior of my application, right? There is a way to tackle that, and this is called profile guided optimizations. So what you can do, you can collect profiles of your application and then feed it to the native image utility. And this way you can build an optimized binary that will be aware of this profile information and will be able to really optimize for your application-specific behavior. And just a few more resources for working with native image. Then I can, maybe share the slides with you or send you later in chat as links. Now, I also want to really briefly mention the GraalVM language ecosystem, right? If you remember on the first slide, we saw all those different languages. And maybe you're wondering, right, if I'm doing microservices, I might as well use some of those other languages. So how do I do that? So with GraalVM, as I mentioned, you have access to all those languages. And with great, GraalVM will also optimize the whole application and will provide you things like tooling and interop out of the box. So some of the languages and what might be interesting for you in those languages are the following. GraalVM also comes with a JavaScript engine that is very compatible with the latest language standards. We constantly test against thousands and thousands of NPM modules, and you can really, to make sure that you can really run your JavaScript code with GraalVM. And if you are interested in some particular NPM module or R package or RubyGem or something, we have this tool on our website called Compatibility Tool, and you can just check and make sure that your desired package works well with GraalVM. And also, if you are using or if you have been using Nashorn, you may be looking for options to migrate. And for that, we have this migration guide for you that will really guide you through this migration process and make sure that it's easy and efficient for you. And one more interesting use case. So I think we have it published on Medium. So you can also be using GraalVM in a way that, for example, like here, your main application is written in Scala, but you are also using React.js for your client side, right? And comparing to Nashorn, not only you will get access to, really modern, latest JavaScript implementation, but also you can get significantly higher throughput if you're running this kind of application, right? The one that has, for example, Java on Scala and JavaScript, if you run it on GraalVM. So comparing to Nashorn, which is in blue line, below here, and the top two lines, the green, the red one, those are GraalVM both editions. You can see how better your performance can be if you run such application on GraalVM. And you can do even, really crazy things with GraalVM. Like, for example, this application where we use JavaScript, Java, and R all together to output this application. So you can really, mix and match languages. And the idea here, not only because it's fun or because you can, but also it can be an easy way for you to extend your existing application with some tools and capabilities from other languages and really making sure that you use the best language, the best tool for the job. And you can even do cross-platform development with GraalVM. So this is an ongoing project that we are working on with the Gluon team, where if you're interested in writing applications for these platforms like iOS or Android in Java, it is really possible with this project from GraalVM and the Gluon team. And if you're interested in things like statistics and data processing and data visualization, for example, in that app that I showed a few slides before, right, there was this cloud plot that was created in R, right? So if you're interested in statistics, you could be using our R implementation, and it is called Fast R, and it will also give you good performance and interop with the other languages of GraalVM. And one more language is Python. So GraalVM also includes a Python 3 implementation. And it is really easy for you to get it. You just, get GraalVM, you install a Python implementation with our utility, and you are all set to be using GraalVM to run your Python code. And I want to share quickly this interesting use case with you. So this is actually a good example of interop, which is done on GraalVM. What we see here on the left, you see like a sample architecture, right? So it was a project of Oracle NetSuite where they were designing a POC for their recommender system. And their main application is written in Java, right? But since they wanted to provide recommendations on their e-commerce platform, they were looking also into Python options, because Python offers really great libraries for machine learning, for, multiple cases of machine learning. So they were using some Java applications, some Java libraries for that, the HTML, but also they looked into using Python. And another thing that they used in this use case was grCUDA, which is a project developed by Nvidia and Oracle Labs. And it's an open source language binding that allows you to expose GPUs to your applications running on GraalVM. So the idea here is that not only they used Python's libraries in their existing Java application, because GraalVM supports both Java and Python, but also they were able to really speed up the model computation time thanks to using GPUs, which is also possible, with GraalVM and with this grCUDA tool. And yeah, here are a few more details about it. So if you're doing things like, machine learning and all of that, you could be really interested in using GPUs to get even more performance for your application. And here are, a few, not links, right? Links are missing here, but basically you can find it on GitHub. You just type, grCUDA, and you can get it and use with GraalVM languages, such as, for example, Java, JavaScript, Python, all of them. And one more interesting app, and that is a blog post and an application developed by our team member. So basically, it's a Polyglot application that is visualizing COVID trends in France based on openly available data sets. And the application itself is written in Java, but it also uses JavaScript for some data validation. It's using Python to retrieve regions named by ID, and it's using R to once again create this plot, right? And here you can see how all those languages really work together, and each language brings its own benefits to output an application like this. And of course, here you can go, even one step further. Since we're already using Python, we might as well not only visualize existing trends, but we can also make some kind of predictions about how those trends will be evolving over time. And this is kind of application that is fairly simple to implement and run on GraalVM. Yes, and very quickly about real-world use cases, because I've been talking, for a while, and I think you already, maybe are getting lost into, because there are so many ways and so many features, and how to exactly can get started and use GraalVM, and what are good real-world use cases for doing so. So I will quickly walk you through some of those real-world use cases. The first one is from Twitter. So if you're using Twitter, you may be familiar with this. Twitter is using GraalVM to run their Scala microservices. So I mentioned before on the beginning of the talk that GraalVM can really optimize Scala code really well. And this is also, experienced and reported by Twitter, where they achieve significant performance improvements by running on GraalVM. And it's in JIT mode, right? So the migration here, in case you're wondering, is very easy. And this is the performance boost that you can get just out of the box by migrating to GraalVM. This one I already mentioned, right? So it was from Oracle NetSuite. They were using Python for machine learning in Java. And you can see how easy it is, right, to extend your existing application, or maybe to write the application from scratch using multiple languages and really using the best tools from each one to, achieve what you want to achieve with your application. And one more interesting Polyglot case. This is from the Dutch National Police. So they were also using R, and it was working well with their existing Java and Scala application. And it also brings up another interesting opportunities. For example, if you have your, Java developers working on Java application, it is really easy for them to collaborate in case you have a data scientist team, which typically use languages like R, right? So it is really easy for them to work together and collaborate, because GraalVM makes it easy to interop between those two languages. And one more interesting use case, this is from Alibaba, and we also have a blog post about it in case you want to access more metrics, more measurements, and read more about how they, adopted and started using GraalVM native image. But as a bottom line here, you can see that their application, when they measured the startup time, it was reduced by 20x, right, from 60 seconds to 3 seconds. And it was also tested under huge load when they had this very big sales festival on the day where they had the biggest number of transactions per day, right? So under really huge load, and they were happy about the experience after testing GraalVM native image under such load. And one more example, so our cloud infrastructure, right, Oracle Cloud Infrastructure is also using GraalVM to run some of its services, such as, for example, here, monitoring service. And what they report is improving peak performance by 10% and also reducing the garbage collection time. And we've been talking about server-side rendering before, right? But just one more use case from real world. So this is from the OKRU, and you can see how they made it easy for them, right, to use GraalVM for server-side rendering, and that was integrated also with their main application written in Java, and all of that was running on GraalVM because it supports all those languages. So a few words about the project roadmap. If you're considering GraalVM, you might be interested, in how new releases come up and what kind of releases are those. Do we have LTS releases? So you can access all of that by this link, and you can plan, for example, if you want to migrate to newer releases, when is that release coming? And yes, talking about releases, I think we will have the next one next month. So yeah, keep following. If you want to access the newest release, it will be available next month. And I want to mention quickly about contributions. So if you want to contribute, right, there are multiple ways. You can report an issue, you can submit a PR, you can extend library support. And one more way, which is not mentioned here, is if you want to do your own, conference talk or gather a meetup or do a workshop. And if you want to do this about GraalVM, you can just talk to us and we will help you with material, with slides, with demos. So that is also a way to contribute to the project, right, when you share this knowledge and maybe share your personal experience with others. So just to summarize, what are the ways when GraalVM will be really helpful for you and when to consider GraalVM? First of all, if you want to achieve high performance, no matter which language you are using, GraalVM can really do it for you. The second one is this GraalVM native image mode, in which you can achieve really fast startup and low memory footprint, and to make your Java microservices really great for cloud. One more is language interrupt, right? So we mentioned a few times before that GraalVM really offers you this interrupt out of the box. It's not something that you need to kind of handle and take care of that logic. This is something you can just get and write application using best tools and libraries in each case. And last one is GraalVM can be easily embeddable in native and managed programs and benefit those programs with its capabilities. That was all. I hope I'm not over time. If you want to get started with GraalVM, here are a few options for you. The first one obviously would be download, right? You can do it from GraalVM org downloads. If you want to follow updates, we are super active on Twitter. So Twitter would be the best way to follow our updates. And if you need help, if you may be run into some issues, or if you want just to talk to the community, to our team members, we also have a mailing list and a very active Slack workspace where you can just, join and talk. We have multiple channels for each component. So I think you can really find the people you can talk to if you have, any kind of issue, or if you just want to discuss any feature or any component. That was it. Here is my name. Here is my Twitter handle. In case you have any question, just DM me on Twitter and I would be happy to help you. That's all. Thank you all.
Awesome, Alina. Thank you. Thank you so much. It was a very good example of many use cases of GraalVM. It was really, really great, I believe. Personally speaking, I want to use GraalVM with Micronaut with some personal projects. I haven't had the time, but eventually I will make time myself. Cool. We only have one question.
Let me know if you try it. I will be really excited to learn your feedback.
So Miss Lee has a question about if the ahead of time compiler, the AOT compiler, is recommended for a big monolith. So And you mentioned the case of Oracle NetSuite, and it might have a similar very big application in Java that it's running as a monolith on the cloud. So would you say that it will fit that will be a use case that fits GraalVM?
It certainly is. I just want to clarify something here, right? So GraalVM native image, this AUT mode is so exciting, and sometimes people only think about GraalVM as this native image mode, right? Yeah. But GraalVM also offers widget mode. And if you have this, huge monolith application, I think maybe GraalVM widget mode would be a better option for you than the native image mode. Because I assume that you run this big application, for a long time, right? It's not an application that you would, bring up and they take down, just for a second or two, like you do, for example, with microservices or serverless. I think that's not the case, right? Most likely you run it, for hours or maybe days. And in this case, GraalVM JIT really would be a better option for you.
Awesome. So keep using the JIT compiler, which you mentioned has a very good performance as well.
Yeah, native image also has a good performance, but honestly, for a monolith kind of application, you can try, but my bet would be that you will see better results with GraalVM JIT.
Awesome, Alina. And well, thank you so much for this presentation. Again, I feel excited that I do want to have the time to play around with GraalVM. We'll keep in touch with you. Guys, please follow Alina on Twitter. I will share his handler of Twitter. And thank you, Alina. Thank you so much for your time. It was a great talk.
Thank you for having me. Thank you for inviting.
Next year, please come to Mexico, and we will go there next year.
I would love to. So yeah, we have a deal.
Awesome.
Thank you.
Thank you. Bye-bye. Hola a todos. Bueno, pues vamos a comenzar en un par de minutos más con la siguiente presentación de Hendrik Evers, que también nos va a hablar acerca de Adobe OpenJDK. Hendrik. Y pues bueno, solo mencionarles que este evento no podría existir sin nuestros patrocinadores también. Entonces, pues les agradeceríamos muchísimo que sigan justamente a nuestros patrocinadores. Y en un par de minutos más arrancamos con la siguiente charla.